Okay, we're going to take a look at global winds. So we all know that hot air rises and cold air sinks. And because we have a rotating Earth underneath us, it causes winds to occur. And you would think that we would have hot air rising at the equator because that would be the warmest place, and cold air should sink at the poles. And it does. Air does rise actually at the equator, and it does sink at the poles. And you would think you would have this one big convection current. As it sinks, it flows downward, heats up, and then rises. But because the Earth spins, it isn't quite that simple. We don't have two big cells. We actually have more, and they're called Hadley cells. And it is still as simple as air rising and sinking, but due to that rotation, it's a little more complicated than that. So we have air rising at the equator. Okay, we have air rising. Cool. We have it sinking here. But air also rises at 60 degrees north and 60 degrees south. And it sinks at 30 degrees north and 30 degrees south. So basically, think of it this way: it goes up, comes down, and sinks here, going in both directions. This is basically, you could put a mirror on the top to the bottom and it's going to be reflected the same way. Well, if air sinks here, it's got to go somewhere. So it's going to flow down towards the equator, and it's going to flow up towards the north. Well, great. But then that air's got to go somewhere. So it actually gets pushed up and starts rising here. Again, it flows south and joins up and sinks here, and it flows north and sinks down at the poles. And now this sinks and it gets deflected, if I'm looking from the surface up, to the right, because it's the northern hemisphere. So it goes clockwise if we were looking from the top down. Or down here, it's going to end up going, if we look from the bottom up, it will look like it's going counterclockwise. So again, we have air rising here, sinking down there, and sinking at our poles. And then we get these convection currents within each of these little spots. So we end up with 3 big convection currents in the north of the equator and 3 big convection currents in the south of the equator. So that's why. But as we watch here, as this air sinks and gets deflected, it's basically an easterly wind, but it's polar, it's cold. So we actually call this the polar easterlies. Well, that seems to make sense. It's not too bad. And if we look at where we live, we're about 45 degrees. This air is basically coming from the west, and this is called the prevailing westerlies. Polar easterlies, prevailing westerlies. And down here where it's rising, air rising is really bad for sailing, if you know anything about sailing. And air sinking is also really bad for sailing, which we'll get to in a minute. But this air flows out and gets deflected again to the right, and so basically where we live is westerly, but where my cousins live in Florida, most of their weather actually comes from across Africa and the Atlantic and hits them. Everything we get comes from the Pacific and hits like Washington State, and then a couple days later hits us in Minnesota. So this is called the northeast trade winds, and it's reflected: southeast trade winds, prevailing westerlies, polar easterlies. I've got a couple different pictures in here. If one makes better sense to you, great. Cold air is a high pressure zone. We've got a low pressure zone, and then we've got these little things called the doldrums. And what happens is, as air rises here, it helps if I hit the right button. As air rises here, sailors called this, when we had sailing vessels, the doldrums, because if they hit 0 degrees, they really didn't go anywhere. There's not much wind. Every uprise and air that's going straight up doesn't really give you much to do in the way of anything. Weather still can be rainy and all that stuff, but it doesn't give you those high pressure winds, because rising air isn't good for sailboats. The other place it's not good is here, where the air sinks. And a downward draft isn't good for boats either. Well, because of that, if we have Europe over here down into Africa, and over here we've got North America and going into South America, well, if we have that equator, right, and we've got those lines, this doldrum area here, the doldrums, was a place, sorry, doldrums are down here. This doldrum area was boring. You weren't going to go very well. But the same thing happened here at the horse latitudes. And I haven't brought that word up, but this part here and this part here are called the horse latitudes. That 30 degrees north and south also happens to be where all of our world deserts are, because sinking air, remember from adiabatic pressure that we did yesterday? Sinking air heats up and it's dry because it's already had the water wrung out of it from the clouds as it was rising over here. So we have rising clouds, condensation occurring, raining out, so nice, lush tropical areas. But these are deserts because sinking air is hot and dry. Well, as ships would come and sail, and there's something called the triangular trade route, they would sail down from Europe to Africa, and then they would head back over to the Americas, go up here, and then go back. It's not exactly a perfect triangle, but they called it the triangular trade route. And it's kind of it's not a very pleasant part of our history. Europe wanted to make money. England wanted to make money from us. And, there's a lot of restrictions at the time. But what they do is they take horses and fine goods that you couldn't get in the Americas. And they would take those and head south, pick up slaves, take them across the Atlantic to like the Caribbean, where then they'd pick up sugar cane and rum. They would sell, horses and slaves. Then they would take those goods of the rum, bring that up through the Americas, sell more horses and now rum and more slaves. And then they would take all this supply, raw supplies from the Americas and the sugar and the rum, and they would take that back to Europe. And this is important because it was all dependent on these winds. If they got to this point and they saw horses bobbing in the ocean, they knew not to turn yet. They knew that they had to wait and get farther down so they could get into these northeast trade winds, because they needed the winds to go this way to pull them across the ocean to get to the Americas. And if they went here, they could spend months there. And the problem was, the reason why it's called the horse latitudes is they couldn't go. They couldn't. Their sails wouldn't take them. They just have to wait for the currents to take them out. And there's those big ships you can't really row. And so the problem is they had to survive. And what do horses need a lot of is water. And so did the humans. So they would literally push the horses overboard and they would drown, but you'd see the horses bobbing, and they called it the horse latitudes for pretty gruesome reasons. So what they do is they take their goods, pick up all the stuff they needed to do. They take the northeast trade winds to the Americas, sail up the Gulf Stream, because here's the Gulf of Mexico, and we've got a current that actually goes here and across. So not only do they have a Gulf Stream there, but once they get up here, it's also the prevailing westerlies. So they could catch the winds across the Atlantic here, follow the Gulf Stream up the coast, and catch the Gulf Stream and the prevailing westerlies back to Europe. And then they would flow down this current. And they knew they couldn't go to the equators. This was no-no areas, the doldrums, and they weren't going to move. And they didn't want to go here because the horse latitudes had sinking air. So that's really what's happening with our original trade route, is they used the winds, and those wind rate trades actually defined the doldrums and the horse latitudes, and to this day we're still called that. Okay, so now let's keep moving. Here are the prettier versions of those Hadley cells we were talking about. We have our hot air rising at the equator, and you see adiabatic pressure change is dropping the temperature, causing clouds to condense. You get nice lush regions of vegetation. These are our jungles. And as air rises, it cools. Well, as it cools, it's got to flow somewhere. Well, it's got more rising air behind it, so it's going to get pushed north and south. And it's because the earth spins underneath it, it comes and drops at that 30 degrees north or 30 degrees south. And you'll notice that this is a much drier region. You're going to get all of our deserts in these regions. And as we go here, That sinking air flows south and heats up and replaces, but it also sinks here, warms up as friction and motion. Well, apparently I need to speak better. Sorry about that. And air is going to come here, and eventually it will start to rise, because kind of think of it this way. You have cold air sinking up here, being pushed down, running into this air, and the only place it can go is up, so it actually rises. And this is where we're going to see those jet streams happening, or where these Hadley cells meet, which we'll talk a lot more about coming up. What you're going to do next, and again, I have more pictures in here just to see which one makes the most sense for you, is this is what you need to be doing now. You need to take out a piece of paper, and we're going to draw this because you're going to want to have this available to use on the test. And you're going to submit it in the next assignment. You're going to take a picture of it, your notes, and show me that you've done this. So here we go. We are going to draw your Hadley cells and our... So take a piece of paper, draw a circle, draw a line straight through the center, label that 0 degrees. Then about a third of the way up, you're going to draw another line and label that 30 degrees north. Okay? About another third of the way up, you're going to draw another line, 60 degrees north. And at the top, at the pole, 90 degrees north, or the North Pole. Now we're going to reflect the same thing down on the bottom. 30 degrees south, a third of the way down again, and you have 60 degrees south. And you can pause this whenever you need, and 90 degrees south at the bottom. Now we're going to put in our winds, and we're going to put in our names. So we're starting at the North Pole. We're going to draw our polar easterlies, that sinking air getting deflected to the right, so it basically is an easterly flow of wind. And the sinking air, it also pushes it up, so we get easterly winds. Think of it that way. Those are called the polar easterlies. The one below it, between 30 degrees and 60 degrees north, which is where we live at about 45 degrees north here in Minnesota, is the prevailing westerlies. So that rising air kind of pushes, and the sinking air also gets deflected, and we have basically a westward wind. So we get our weather from the Pacific, and we live in something called the prevailing westerlies. So the next we have our northeast trade winds. So as that air sinks at 30 degrees north, it gets deflected to the west, north of the line, and south of the line it gets deflected east. So again, my cousins in Florida, their weather comes from the Atlantic. In the prevailing westerlies, our weather comes from the Pacific. And those again are the northeast trade winds. So between 0 and 30 degrees south, again, we're getting deflected as we look at it to the left. So that's the southeast trade winds, because again, everything on top is reflected on the bottom. So if you can memorize the top half, you just have to remember instead of northeast, it's southeast, and everything else is just a mirrored image if you reflect it down. So we've got the southeast trade winds. Now between 30 degrees south and 60 degrees south, we have a prevailing westerlies again. Because again, we have sinking air at 30 degrees and rising air at 60 as the 30 and the 90 degree airs come together. The only place that 60 can do is go up. And we have the prevailing westerlies. And we have one more piece of information to fill on the inside, and then we're going to label those horse latitudes and our doldrums. So again, last one, polar easterlies. And again, if you need to, you should be pausing this anytime you need to get this copied down. On the assignment, I actually took a screenshot of, well, actually took a picture and uploaded it of this, so you can look there as well. Now, let's label the other parts. We got to put in the doldrums, which is at the equator. At 30 degrees north and south, those are our horse latitudes. I think typing has ruined my handwriting. It was never good to begin with, but it's much worse now. I don't write out nearly as much as I used to. All right, now we're going to look at those rising and sinking air currents. So we know we have hot air rising at the equator, and I should have done cold for sinking, but I wasn't that smart to think of it. But we have hot air rising at the equator, and it gets deflected north and it gets deflected south, and it sinks because of the rotating Earth at 30 degrees north and 30 degrees south. Again, our world deserts are at 30 degrees north and 30 degrees south. Probably going to be a test question if I've mentioned this a number of times. And again, because we have sinking air at the poles and we have sinking air at 30 degrees, as that air comes together at 60 degrees north and south, we have rising air. So again, we have sinking air at 30 and 90. We have rising air at 0 and 60. And again, reflecting these back off. What you see on the top is the same as the bottom. And then we can put in our convection currents. I kind of already have it now with those arrows, but if I want to be just even a little more clear, you can see those cells rotating in the direction it rises and it sinks. In this case, it sinks at 90 and it rises at 60, whereas the equator is rising at 0 and sinking at 30, reflected again down, just the mirrored, reflected image down. And we need one more big cell. And where would that be? Well, that's between our 60 and our 90. That's the cold one. We also tend to have high pressure where it's cold because it gets stuck and packed together, and air that's cold can shrink and be more dense. So you need to go ahead and say, I have gone through the notes. You need to take that image, your version of this that you have handwritten, and you need to take a screenshot or a picture, and then you need to upload it on the next assignment. And just to show you where that is, let me get out of here, leave. I'm hoping this should go because I'm on the same tab. All right, so if we go down here, I may have one more thing after this, so don't get too excited if you think you're just about done. Wow, okay. My computer's being very slow today. And apparently freezing up. Okay, so anyway, go back into day 3. Right underneath this global winds notes is your global winds drawing. That's where you submit. Have a good day, and as always, ask questions.